Why the study methods you used in high school don't work in university. Most of us went through high school with a simple mentality when it came to studying for midterms and final exams. If I cram the information into my brain close to the exam time, I'll be able to retain it just long enough to regurgitate it during the test. However, the curve of your ability to memorize the content probably looked like this. Sure, you got through, but in some cases you came perilously close to the zone of poor retention. For high school, that may have been okay. You may have passed the course, perhaps with a decent grade, but that won't work in our program. The reason is that you'll want to use the knowledge you learn here over the entire 4 years of your time, not to mention well after graduation. As well, there's a lot more information you'll need to know for each midterm and final exam at university, so the cramming method won't work all that well. The solution to the problem is, don't cram. In order for you to retain the massive amount of information you'll need to know, you'll have to review the material more than once. This idea was originally put forth by Hermann Ebbinghaus, a German psychologist who pioneered the experimental study of memory, and is known for his discovery of the learning curve, and perhaps more importantly, the forgetting curve. You've probably heard of the learning curve. It says that the more you experience a certain body of knowledge, the better you'll be able to remember it. It's one of the hallmark traits of the way we like to teach at Ryerson University, experiential learning. The forgetting curve, on the other hand, shows us that if you only look at something once, you'll forget it after a few days, and will have to learn it all over again from scratch. That's the red line in this diagram. If you project this over a whole semester, you can see that you're relearning and relearning the same stuff over and over again if you don't review often enough. However, if you review the material several times, especially soon after you've been taught the information for the first time, you'll retain the material for a much longer period, eventually perhaps even years. That's the kind of learning you want to do. While it seems like more work, it's far better than learning from scratch every time you look at a topic over the course of a semester. So that's the first tip. Review your notes often, and don't cram. But what do your notes look like? Here's a typical point form set of notes from a topic in class. If you're like most students, yours probably looks something like this. If you want to find the important points in this, it's difficult to do. For the final exam, it's just pages and pages of text. Nothing really stands out. Your brain doesn't work this way. It has a difficult time digesting all this linear material. Here's the same set of notes using something called a mind map. This is the way your brain works, by making connections between different elements of the material, grouping and cataloging related items into categories. This mind map is especially useful, since each group is a different color, and the most important items are shown as red branches within the tree structure. By quickly glancing at this, you can see how everything fits together, and the highlights are easily found within the structure as a whole. Making this mind map was easy. Starting with the core concept, Sound 101, we first learned in class about the nature of sound and how it consists of moving air molecules. The movement consists of compressions and expansions of these molecules, creating a sort of wave action in the air. These waves can be focused and reflected by various means. Next, we discussed the human ear. There were lots of elements inside the ear that we looked at, and each one had a particular function. But the most important point from this is that we use the model of the human ear to design microphones. Finally, we looked at sound in more detail. Frequency used to be measured in cycles per second, but now we call cycles per second hertz, after Heinrich Hertz. The frequency of sound that we can hear is between 20 and 20,000 hertz, which can also be expressed as 20 hertz to 20 kilohertz. Musicians usually refer to frequency as pitch, as in the pitch of a note. There's a great range of sound level that we can hear, and this is called loudness. It's measured in decibels, or dB for short. It's a compressed logarithmic scale, so every time the sound level doubles, that's a 10 dB increase. The loudness scale ranges from 0, or complete silence, to 220 dB, which is unbearably loud. We found out that loudness level above 85 dB for an extended period of time can cause permanent hearing damage. Wavelength, or the length of one cycle of the sound wave in air, varies according to the frequency of the sound. The higher the frequency, the shorter the wavelength. Lastly, we explored the Doppler effect in sound, which is why a fire engine's siren goes down in pitch as it travels away from us down the street. It's because the wavelength gets longer, and therefore its frequency decreases. And that's an entire hour's lecture in about 90 seconds, elegantly described in a mind map. The mind map is a very easy thing to study from, and you can even use it to find out what you don't know. Study your mind map for a minute or two, then start fresh and see how much you can write down to recreate it. If you're missing some points, especially those things you know are important from the class, those are the areas you'll need to study more. Why study the whole thing if you already know most of it? So to recap, Review your notes often, and not just before the exam. Don't cram, and try using mind maps. Hopefully, these tips will help you study better at university, and will help you retain more for longer periods of time. Good luck in your classes.